Did you hear about this?
We're going to get the drug prices down, not 30 or 40%, which would be great, not 50 or 60, no. We're going to get them down 1,000%, 600%, 500%.
That sounds amazing, but let's look at the math behind it. Let's focus on the 1,000% decrease in prices. And let's suppose that we have a prescription that cost us $50. How much will it be after the 1,000% decrease? Well, let's use a little algebra to figure that out. We'll call the new cost X, and then we'll use our percent of change formula, which is the percent of change is the new price minus the old price divided by the old price. We know the percent of change is a 1,000% decrease, so that's negative 1,000%. The new price is X, and the old price is 50. Now we'll change the percent to a decimal. Negative 1,000% is the same as negative 10. We'll multiply both sides of the equation by 50, and then add 50 to both sides. So the new cost is negative $450. In other words, if the price drops by 1,000%, they will pay you $450 for the prescription. Now let's face it, in the real world, that doesn't happen. So a price drop of negative 1,000% simply doesn't make sense. Now let's look at our $50 drug in a slightly different way. We've got a current cost of $50 for our drug. And let's make a table and see what happens as we decrease the price of the drug. Let's start with the simplest case. The new price is still $50. In other words, the change in the price was 0. That means there's a 0% decrease in the price. But what if the price actually does go down, let's say to $40? That's a $10 change in price, and the percent decrease would be a 20% decrease. If the new price goes down to $30, then the change in price is now $20, and the percent decrease from the original $50 price is a 40% decrease. If the price goes down to $20, then the change in price is $30, and we have a 60% decrease in price. A price of $10 means we've decreased the price by $40, and that's an 80% decrease. And if the price decreases all the way to $0, in other words, the drug is free because it's $50 cheaper, that's a 100% decrease in the price. Now we were promised a 1,000% decrease in price, which is a whole lot more than a 100% decrease. But for the sake of using what we see in the table, let's continue the patterns that we see. Our percent of decrease is following a pattern. 0, 20, 40, 60, 80, 100. So a 120% decrease would come next. The change in price also follows a pattern. So we've got $0 change, $10 change, $20 change, $30, $40, $50, $60 change would come next. So now let's look in the new price column and follow the patterns we see there. The new price starts out at 50, then 40, then 30, then 20, then 10, then 0, which means negative $10 would come next. So there we have it. 120% decrease in price means that they are now paying us $10 for this prescription. The line between having to pay for the prescription and being paid for the prescription is right here. So anything from a 0% decrease to a 100% decrease in price is mathematically possible. But anything over a 100% decrease in price just doesn't make any sense. It would mean that we're getting paid for the prescriptions. So the bottom line is, if somebody tells you that they're going to decrease drug prices by 30 or 40 or 50 or 60%, all that makes sense. It may or may not be politically possible, but it's definitely mathematically possible. But a 1,000 or 600 or 500% decrease in price, it just doesn't make any sense. It's not mathematically possible.